Yes, we have notes. Do you not have a note packet?
We have an extra.
Yeah, you don't know.
Oh my goodness. That was yours. All right, inverses. So, please pay attention. Please pay attention. Focus. I can find the inverse equation of a table, linear graph, or just given a function. So that's what we're going to be looking at today. So let's first make a table of values for each of the graphs, and then explain what you notice about the tables. So give me some points along the line on the left. Give me some points along the line on the left. I'm not going to put them in the table quite yet. Give me a point on the line on the left there, Connor.
2, 0.
Okay. Give me another point along that line, because I'm going to need 4 total. Yeah.
0, -4.
Okay. How is this graph counting? Can anybody tell me how it's counting? Well, it's counting by 2's here, but what are all these little lines then?
Quarters. Other line.
No, they're not quarters.
1/4.
That's a quarter. Halves. Thank you. Half, 1. 1 1/2, 2. Just so you guys are aware. Kaylee.
4.
Yeah. Give me another one. Where is it meeting at 1? 1 comma?
-2. Oh.
How about at 3? 3 comma?
2.
Good. So I'm going to put those in the table. You can't even read that?
Oh no, like not. I can read that. Like I can't read the.
Oh, the graph. That's why it's good, for you to have that. I'm like, you might need to get your glasses, checked again. All right. Shh. You need to write stuff down, please. The next one. Give me an ordered pair along that graph on the right. Give me an ordered pair along the graph on the right. Emma.
0, 2. Is that 0?
Yes, you're all right. What's another one? Somebody else. Cassie.
-4, 0.
Okay, something else. Connor.
4, 4. Again? Yeah, double whammy.
What's another one? Justin. Nope.
Okay, 2.
3 is at 3.5, and I don't really. Let's try to avoid those half points. Yeah.
2, 3.
2, 3. Do you understand why it's not 3, 3? Justin or no? Okay. One more. Where is -2 at? -2. Yeah. What is it at?
Me?
Yeah, Connor.
Oh. Wait, what's Connor?
Oh.
Me?
You were the one that had your.
Connor. You.
Oh, he was answering. I didn't know if...
Yeah, because I thought you were talking.
Okay. One of you just answer me. Yeah, I know. Thank you.
Which one? You put it right next to each other.
Name one Connor and one Kanye.
-2 and 1.
-2, 1.
Oh.
All right. Shh. So I'm going to put those points in the table. Okay. Look at those tables. Look at those tables. What do you notice?
They're flipped.
Somebody said opposites, but opposites really like a change sign, so it would be better to say what word? They flip the x and the y, right? So the x and y are flipped because f of x means y, right? For those of you that keep wanting to repress the memory of me teaching function notation because it bothers you so much. Okay. So you should notice that the x and f of x were flipped. So go ahead and write that down, and then we're going to flip to the next page, yeah.
Is it okay if you write X and Y, or do you want us to write F of X?
X and Y is fine. That means the same thing.
So many flipping now.
It's in my fridge. Don't take... There's something up there that is also Dalton, so be careful. All right, guys. Just because you flip the page doesn't mean you can start talking. All right, so what is an inverse? An inverse is the set of all ordered pairs obtained by interchanging the x and the y values of each pair of the original relation. So, isn't that what we just did? We just switched x and y?
Yeah, sure.
So, inverse just means you switch x and y. The notation for an inverse of a function of f of x is f to the negative 1 of x. So, this means that this is the original, and that little negative 1 there means the inverse of f of x. So this means the inverse of f of x. So these two lines are the two lines from the previous slide on one. When you graph them, the inverses are symmetric about the identity line. So the identity line is the same thing as the parent. So those words are interchangeable. So this is the parent or the identity. That also is the parent. What that means is if you were to graph the parent on this, if you guys want to plot the points for the parent on this, it might be helpful for you guys to see this. So this is the identity line or the parent. Yes. Okay, what do you notice? Guys, you are very, very squirrely today. Can you guys please listen? Just can't sit still. I feel like squirrels just run about and they're just everywhere.
Calm down. I don't even know that.
Anyways, shh, everybody go into Kaylee's thought and think that it's Tuesday or something, please. All right.
Feathers.
Along the identity line, what do you notice about that? What could we do with your paper or the whiteboard? If I could. What?
Fold it.
If you folded it along that line, wouldn't the two lines meet on top of each other?
Oh, yeah.
That's the inverse. You switched x and y, and they are symmetrical over y equals x. So f of x is 2x, it's this red line here, minus 4, and f inverse of x is 1/2 x plus 2. So this is the original, and this is the inverse of f of x. All right. So those are the same lines that were on that first slide. So we're going to get started on some examples just a second here. And we'll have a few slides to get through. The first few will be pretty quick. I'm glad. No, that's good that he did that. That when he gets it out, he'll know what that means. Now, please don't poke my desk.
Oh, yeah, I'm sorry.
It's okay. All right. Riley. Thank you. All right, for each function, find its inverse. So all we have to do to find the inverse is switch x and y. So what would the first ordered pair in that table be then for the inverse? Kaylee, if you're just switching x and y. Perfect. Riley, what would the next one be?
5 negative 4.
Perfect. Miguel, what would the next one be?
7 0.
Josh, do you want to do the next one?
Sure. 9-1.
Mike, how about that last one?
11 2.
Awesome.
Yeah, good job, Mike.
Tables are super easy. That is the inverse.
Do we have a lot of tables on the board?
I can't remember. I was even the one that made this, and I can't remember at this point. I've been making so many things. Because I make so many things for everything.
What?
Wow, you can get crazy on this.
Probably pick that up.
Okay, please listen. Focus. Group, over here. Stop. Jayla. First ordered pair of the next one there. Thank you. Alyssa. Denari. The second one there, and we're on the third one down. Good. Justin Powers. Brian.
4-2.
Perfect. So questions on finding the inverse from a table. Okay, flip to the next page, then we're going to talk about graphs next.
I know, yeah.
I told you that. All right, it will get a little bit more difficult, but not really that much. Shh. So graph the inverse of the given line. So to graph the inverse of the given line, first you're going to choose 3 points. First you're going to choose 3 points off that line. So give me some points off that line. Somebody raise their hand and give me some points off that line. Colin.
0, 2.
Kaylee.
Hang on. 1, 4.
One more. I just need one more point here. Connor. I didn't call on you. You're not even Connor.
What he said.
What is it?
You're going negative 1, 0.
Thank you. All right. So first you're going to choose those points. So I have negative 1, 0, 0, 2, and 1, 4. Then we are going to switch x and y. So if I switch x and y in those ordered pairs, Justin Powers, what would negative 1, 0 become?
0, -1.
Cassie, how about 0, 2? Jordan, how about 1, 4? Next up, plot those points. Make sure you're careful about the scaling on your graph. 4, 1 doesn't fit, so I'm just going to stop at the 2 that I can plot and connect them. Mike? That's what the inverse is. The inverse means you switch x and y. And we're trying to graph the inverse. So that's the point. Does that make sense now? All right. So we could easily write the equation of this one. We could easily write the equation of this one, correct? Yeah, because it's crossing over at negative 1. So it'd be p of x equals, because this one's, but it would be p of negative x, because it is negative 1 to the x, is because it's the inverse, sorry. It starts at negative 1, and it goes up it goes up 1 over 2, which is 1/2. So that would be the inverse equation here. That is easy to write from this graph. That means inverse. This negative 1 here means the negative 1 there means the inverse of p of x. Can you please put that out, take that off your face? All right, so what do you notice about the graph and the original line? What are they a reflection over? Which line are they always a reflection over? Which line is this? The parent or the identity line. Both mean the same thing, but it is a reflection over that. So you should notice that every time. It is reflected over the line y equals x, which is the identity or the parent. They are reflected over the parent/identity line. All right, questions so far on the graph before we do one more example? Get that written down. Okay, let's get me some points off this line. That's the first step. Choose some points off the line. Go ahead.
0, 1.
Okay, that is 0, 1. Look at the scaling on the graph. That is 0, 1. Give me another one. Somebody give me another point off this line. I need 3 of them total. Kaylee.
Negative 1, 4.
Oh, someone's on bender.
What's another one? 1, negative 2. Good job, Alyssa. Okay, then we switch them.
We only have to do 3.
Yes.
Then you switch x and y. So Jayla, if you switch x and y of 0, 1, what does it become?
1, 0.
Grace, what does negative 1, 4 become? Lamar, what does 1, negative 2 become? You switch x and y, so just switch them. So instead of 1, negative 2, you start with the negative 2, so you'd say negative 2, comma, 1. So go ahead and plot those points.
I would if I could see the lines.
I don't think I got it, but
They really do.
what?
You can barely see these stuff.
It's really hard for us to get a software that actually
Invent one.
Yeah, invent.
I just plotted the wrong point as well.
Invent graphics.
Thin dotted gray lines.
It's just hard for us to make graphs without it using, those lines just don't show up.
You could make the lines larger.
Guys, stop talking. Alright, is it easy to write the equation of this line? Do we even know where it's crossing at?
No.
No. This equation is hard to do. So the next slide we're going to talk about algebraically. Because sometimes you can't write the equation from the graph. Alright? So sometimes you're going to have to know how to do things algebraically. But before you do that, what do you notice about these two? What's the same thing we said last time?
They are reflected over the apparent identity line.
They're reflected over the identity or the apparent line. Good job. So, again, your y-intercept is not something you can see. It is not at an exact point. It isn't even at a halfway point. We have no clue where it is. So what do we do when that is the case? What do we do when that is the case? So we have one more slide, and we do it by algebra. So here's how this is going to work. So when you're ready,
Man, this is so easy. It feels good.
That's what she just
so
said.
that's what we're talking about right now, Josh. I was saying how we don't know where the y-intercept is because it's in between 2 points. So sometimes we can't do it from the graph. So what do you do if you can't do it from the graph? You have to, my voice is always gone at this point. But that just means that you're going to have to know how to do it by algebra. That's why, the easiest ways are tables and graphs for you guys. The most conceptual way is algebraically for those situations that you can't get everything. So what do?
It feels good to know.
The first thing you do, because remember the inverse means you switch x and y, right? Is you switch x and y, or it could be x and f of x in your equation. So the first thing you're going to do is switch x and y, or it could be x and f of x, depending on what you're given, in your equation. So, do you see that y is here and x is here?
Yeah.
We're just going to switch them. We're not done yet. And then you have to solve for x. Solve for y, because you want to get into slope-intercept form. To get into slope-intercept form. But you're finding the inverse. This is the original, and you're trying to find the inverse. So to find the inverse, it means you need to switch x and y. That's why you're doing that. So what do you have to do first, Emma, to get this into slope-intercept form?
Subtract x. No. 3.
Yes.
I knew that.
RC, what can you do next to get y alone?
Divide side by -4.
So this is like a 1 over -4, so that's -1 over 4x. A positive and a positive is a...
Negative positive.
Oh, I said a positive and a positive. How about a negative and a negative?
Positive.
Still a positive. Equals y, and this is our inverse, so I'm going to put the little -1 there. So notice, this is a situation where you probably couldn't tell on the graph that it's at 3/4, right?
Sure.
So this is why it's good to be able to do this, because if you were to graph this and then plot the points on the graph and then do it that way, you probably couldn't see where the y-intercept is to graph that line. Okay, what is f of x the same thing as? I'm going to make that a y first. So we switch x and y. So x equals -1/3 y minus 5. What do we have to do next? Emma.
Add 5.
Add 5. Put it into slope-intercept form. Now what? What do I have to do now? Riley?
I think that you're supposed to multiply 3.
Could I multiply by a -3 to make it positive as well?
Yeah.
Yeah. And if you multiply 3 on both sides, that means you're multiplying everything on the other side by 3. And it's the inverse, but we started with f of x, so I'm going to change that back to f inverse of x. I just think it's easier for you guys to work with y's than f of x.
Definitely.
Yay.
Yay, we're done!
Dude, it feels good